All right, good morning, everyone. This is lesson 8 in your notebook, or is page 18. We're going to do part of it today and part of it tomorrow. Independent events. The events have no effect on each other, so simply multiplying together the probabilities of each event occurring. That's like independent is when you're rolling a dice and flipping a coin. They mean nothing to each other in terms of what's going to happen. Dependent events. The first event, or whatever happens first, will change the probability of the second event. So multiply the probability of the first event by the second event. What that means is the total number of names in the bag. This is what dependent means. So I'm going to leave that there a minute so you can copy those words down. Now we're going to go to the examples, and like I said, always these definitions will make a little bit more sense. Now, compound events, we learned yesterday, that's when two or more things are happening, like you're flipping two coins or you're flipping a coin or dice. So here are the examples. Example 1, it says landing on a green as you spin it and rolling an even number. Okay, so this is divided up, your notes are divided up into events. The first event is going to be the spinner. Well, the probability of landing on a green is 1 out of 4. 4 colors and there's 1 green. The second event is the dice. What's the probability of landing on an even? We know this is 3 out of 6, but that reduces to 1. The events together. I'm also just going to go ahead and say this is independent. Those two events mean nothing to each other. So I'm going to take my 1/4 and I'm going to multiply by my 1/2, and that's going to give me 1/8. Now, what does that mean? It's a 1 out of 8 chance that when you roll and spin these together that you land on a green and then land on an even number. Okay, so second event, or second example, you roll a standard number cube twice. So now you're just rolling the number cube twice. What is the probability of rolling an even number and then an odd number? So what's the probability of rolling an even number first and then an odd number second? So the first event is the even number, and like we always say, it's always going to be 1/2. And then an odd number, same thing, 3 out of 6, which is 1/2. But it wants to know what's the chance of rolling even first and then an odd second. So you're just going to multiply the 1/2s, which gives me 1/4. So there's a 1 1/4 chance that the first roll is an even and the second roll is an odd. Okay, that's probability number, example number 2. And this one's also independent. It doesn't matter what you roll the first, it doesn't affect the second roll. So those are 2 examples. We're going to go to page 19. Okay, here's the next one. You're flipping a coin and rolling a dice. What's the probability? Flip a tails first on the number cube, and then a number less than 5. 1, 2, 3, 4, 5, 6. Number less than 5 does not include 5, so it includes these 4. All right, so let's take the first one. Probability I land on the tails is 1/2. Number less than 5. There's 4 numbers here less than 5, so that's 4 out of 6. And then that's going to reduce to 2/3. Going back to our definition, we're going to multiply these two reduced fractions, and we get 2/6. And we notice those are 2 even numbers, so we can divide by 2. which will give us a 1/3. Okay, what does that mean? It's a 1/3 chance of me rolling a tails, or, I'm sorry, flipping a tails, and then rolling a number less than 5 on the number cube. Okay, the next two are going to be different. Oh, once again, this is independent. Now we're going to go to the dependent examples. All right, so this one's going to be a little different. Each letter in the word assessment is written on a card and placed in the bag. So each one of these letters is written on like an index card and placed in a bag. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. We'll put that there. What's the probability of picking 2 S's in a row without replacing it? So what's the probability you're going to draw an S out of the bag and leave it out, which is going to change the total, and then draw another S? Okay, so let's take the first event. Draw it. There's 10 letters in the bag. We'll put down here 10 total. And right now we're talking about S's. There's 4 S's in that bag right now. 4 letter S's in that bag. So there's 10 total and there's 4 S's. So the probability of picking an S first is 4 out of 10 because there's 4 out of 10 there in the bag that are S's, and that reduces to 2/5. Now here's where it changes. I take out an S out of the 10. So I'm going to leave it out. This is going to change my total. So now I have 9 total, and I also have 3 S's. So let's take a look at that. I started here, I took one out, and I left it. That changes my total and changes my total S's. Now I have 3 S's out of 9. What's the probability of picking another one out? Well, there's 3 out of 9 now, and that reduces to 1/3. I'm going to go back and repeat this. I started with 10. Probability I take an S out and leave it out. So now my total changes for both of these situations. 10 goes to 9, 4 goes to 3. So that's 3/9. Now I have 2 fractions to multiply. And that's going to give me 2/15. Again, what does that 2/15 mean? There's a 2 out of 15 chance that I'm going to draw an S, leave it out, and then draw another S. The biggest key here is to change the total. If you miss this problem, it's going to be right here in this area. Okay, last one, and this one's, I'm going to put down here dependent because it changes the first event from the second. All right, last one. This one's a little lengthy, but we're going to do it today. All right, there are 9 girls and 12 boys in the class. She writes each one of their names on a piece of paper and puts them in a bag. So everybody's name is on a piece of paper, and that's going to give me 21 total. Let's go ahead and put that down too. 9 plus 12. She is going to draw 2 names out to decide who gets student of the week. What is the probability that she picks a boy's name first and a girl's name? Now, when she picks the name out of the bag, she's not putting it back in, so that total is going to change again like it did in the problem before, so it's dependent. Okay, so probability pick a boy's name first and a girl's second. Okay, so this is the boys. And we'll put this right here. Okay, so let's take a look. I have 9 girls plus 12 boys, and that's going to give me 21 total. Okay, here comes the boys. 12, excuse me, out of 21. That takes care of boys. 12 boys out of total 21. This divides by 3, and it gives you 4/7. Okay, so this is the probability of the first event. Now, we took the name of the boys out and left it. So here's the changing part of here. 9 girls did not change. Now there's 11 boys, and the total is also going to go to 20. So let's talk about that real quick. This is the boys picking the name of a boy out and leaving it. So the 12 boys goes to 11. The girls does not change because we didn't pick the girl's name out. And the totals change because we left one of the boys' names out. So now, what's the probability we pick a girl's name on the second draw? So there's 9 girls out of 20 now. And that does not reduce, unfortunately. So now we have 4 over 7 times 9 over 20. This is going to give us a big number. 36 over 140. And that's going to be 18 over 70. I'm just reducing it by 2. It's easier to do in my head. I'm going to reduce it by 2 again. That's 9 over 35. I believe that's all we can reduce down to. So what does that mean? It's a 9 out of 35 chance that if we have a total number of 21 students, 9 girls and 12 boys, that we pick a boy's name first, leave it out, and then pick a girl's name second. We will talk about this kind of a problem again in the next couple of days, but I wanted to get it in your notes. So again, that's these last two are dependent because the totals change, because we left the name out or we left the letter out. So the totals change.